So here now we'll see the demonstration of the testing of MCCB, that is molded cage circuit breaker. So here you can see the setup for the testing of MCCB. So this is our DT100 LNT make MCCB. This we are going to test. Okay. So here we can see the specifications of our MCCB. So rated voltage is 415 volts. Frequency is 50 hertz. Then the breaking current or breaking capacity is 5 kilo ampere, as you can see. The rated current is, here you can see, 80 ampere. The thermal threshold we can set between 60 to 80 ampere. So there is a setting provided which will set the thermal limit between 60 to 80 ampere for the overload condition. And the instantaneous tripping we are getting is for 700 ampere. So once current flowing through this is 700 ampere and above, the MCCB gives us instantaneous tripping. Okay, so this is the specification of the MCCB which we are going to test, DT100 LNT make MCCB, and these are the various ratings of the MCCB. Now here we can see the open view of the MCCB. So the internal construction we have shown in the write-up. So this is the open view of the MCCB, where you can see these are the 3 incoming terminals and we have 3 outgoing terminals. So these are the supply side terminals and these 3 terminals will go to the load. Okay, then these are the deionizing plates. These 3, you can see these 3 are the deionizing plates. So whatever arc is struck, this arc will be driven in these deionizing plates, and that will increase the resistance of the arc and arc will quench. So again HRI principle is used here also. Then you can see these 3 thermal bimetals. So these 3 thermal bimetals in order to provide you the overload protection, and here inside this, on this side and on this side we have, and middle also we have 3 magnetic pickup coils which will provide us the short circuit protection. So these 3 these 3 thermal bimetals, they have provision of adjustment. So we can adjust this current between 60 to 80 ampere for this thermal bimetal releases. Okay, so at present in this DT100 MCCB, it is set for 80 ampere. So we want to test it for 80 ampere, means we have to pass through this 2 times, 2.5 times and 3 times the rated current. That means we will pass 160 ampere, then 80 into 2.5 ampere and 80 into 3, that means 240 ampere. And after passing these currents, we have to note down the tripping time, after how much time the MCCB is going to trip. So for that I have connected only 2 cables, one to the incoming side and one to the outgoing side, because you know there is a common operating mechanism for this MCCB. So one wire will be sufficient, one cable is sufficient for incoming and one cable is sufficient for the outgoing. Okay, because a common lever mechanism is there. So once MCCB trips, all the poles will simultaneously open, and these 2 cables I am going to connect to the current source. So this is connected to common and this one is connected to 350 ampere, isn't it? So we are going to use this switchgear testing kit which is of 350 ampere capacity. So here you can see this is 75 ampere, second tab is 150 ampere and third tab is 350 ampere. So I have put it to 350 ampere. So this counter selector switches also I have to connect to 350 ampere, and the tab I have chosen here is common and 350 ampere. So that sequence has to match, right? And I have to pass through this 160 ampere and 2.5 into 80 ampere and 3 into 80 ampere, that much current through this MCCB. One more MCCB we have. So this is another MCCB which is rated for 100 ampere. So this is at present this breaker is in off position. So you can see here OFF off. So this is now on position. The MCCB I have put it in a closed position, and here you can see the indication on. Now here you can see one push button is provided. So this is for self-testing purpose of the MCCB. So once I press this red push button, the MCCB will trip, and that is the self-testing facilities provided with some of the MCCBs like this one. So let us see now. I will press this red push button. You can see the MCCB will trip. Yes, MCCB is tripped here and it has occupied the middle position. So in this way, MCCB has 3 positions: on position, upper one, bottom position will be off position, and middle one is the trip position. So in this way the MCCB is presently, I have manually tripped so that it is taking the middle position. Now again, to close the MCCB, I should not go from trip position to on position directly. See, it is not getting on because interlocking is there. So from trip position, compulsorily I have to come to off position. See, it is off position, and then from off position I have to go to on position. See, now it is on, right? So once again, trip. Okay, so from trip I cannot go to on, compulsorily off, and from off you can go to on position, right? So in this way we can have this self-testing facilities provided with some of the MCCBs like this. Okay, of course the one which we are going to test is here. For this DT100 MCCB which we are going to test in the lab, that self-testing facility is not provided. Okay, so now in the second part we will see the actual demonstration or actual testing, where we will pass 160 ampere current through the MCCB and see the tripping time. Okay, so thank you.